It's a good shortener, so you might as well, take advantage of it while you're in here. Okay. So anyway, when I look at all these forms that you've just written down, I notice first off, it says they're all different forms of a quadratic function. So all three of these make parabolas when you graph them. The first one called vertex form. So red. So vertex form is nice. We worked with it last chapter. And the great thing about it is that it shows transformations. A number here and here will tell us that the parabola was shifted up or down, left or right, right? Standard form is not helpful that way. Vertex form is actually easier to graph than standard form. But one thing that all three of these have in common, well, they all have x, and then they all have y, or f of x, but they also have the letter a. I see an a in this form, I see an a in this form, and I see an a in this form. And a always means the same thing. If it's negative, it's flipped over. If it's more than one, it's a skinny parabola. And if it's less than one, it's a wide parabola. So that holds true. But when I'm looking at a standard form quadratic function, I can't visualize if it's left, right, up, or down. The numbers don't tell me as much information. And then intercept form we often refer to as factored form. So right now, if I was to go to desmos.com, and I typed this in, it looked at the graph, it would be a parabola. This is a parabola. One thing that you've practiced before is distribution, the distributive property. Some people call this double distribution, or some people call it the FOIL method. I could rewrite this by doing x times x, getting x squared, x times 7, and getting 7x, negative 4 times x, and negative 4 times 7. And I'll combine my terms in the middle, and it would leave me with this. Now, in Desmos, the graph of this and the graph of this are the same thing. These are the same thing written differently, okay? Different forms of the same function. One of the standards of your curriculum is that you just practice understanding that math problems can be represented differently, okay? So all of these could represent the same exact graph or parabola, and they're written in different ways. So by the end of the chapter, you're supposed to understand how to change equations, how to go from this one to this one, or this one to this one, or vertex form to standard form, and that you understand all three forms. Okay? And how to graph them all, and how to solve them all. So it's kind of like with linears, you've got slope formula, slope intercept form, point slope form, you got all that? You got all the same thing with quadratic functions. So these are the three main ways that we're going to see our equations represented in chapter 2. Any questions? Tomorrow we have a bell work quiz scheduled. This goes in as a quiz grade, but it's really just a notebook check. Okay? So what you want to do is you want to make sure you have all your bell works with you that we've ever done. Okay? I'll give you a piece of paper, and I'll say on August 20th, what was number 2? Then you'll flip to August 20th, and you'll write down number 2, and then you have it right, and it goes into focus as a high quiz grade. So this is like a little extra bump for people people who are participating every day and on task, and you come to school and you do your makeup work, it should be a good quiz grade. Okay? Do you have a question? Okay. Okay. And all you do is you don't do any math problems. You don't do math problems on it. You flip through your notebook and look for dates and write answers down. And that's how I check that you've been doing better for the month of August. Okay. Let's do that tomorrow. How do you know what? Yeah. There'll be a couple people in every class who say that. So for chapter 1, I might allow you to come after school and like correct it and fix it, and that will be like a meaningful experience that will help you remember to write dates. And part of it is just helping with organization, you know. Yeah, that happens, and then a lot of people say, "Well, I didn't know how to make up bell work." Like, I was actually in there, and I'm like, "Well, you do. You are supposed to. That's why I post videos." So, can everybody write today's assignment down? You're gonna want that in a minute. Okay. So for now, I'm gonna give you a handout, and you're gonna want to keep this handout for a long time because this is the start of chapter 2. By the end of chapter 2, you will not remember this day. It'll be a distant memory. Or better yet, by December, when you're preparing for your midterm exam, you won't remember this. So this is a note handout with all the steps to today's lesson on here. Don't lose this. I'm going to hole punch it, keep it in your binder. Let's get into it. Or if you have a highlighter and you want to get some colors out to dress this thing up so it stands out in your folder, go ahead, go for it. Get out a highlighter or two. Also get your calculators out. The math is easier with a calculator. Cool. Okay, so I've assigned you 2 of these to do on your own. So the idea is you'll be able to use this handout, see all the steps clearly, so you know just what to do. Such a blur. All right, standard form. I see that the number in front of x squared is called a. The number in front of x is called b. And the last number is called c. Next, I see a formula for the axis of symmetry. I like to rewrite this. This is how the book will present it. That's how it would look on the SAT. And they will put that on the SAT. I like to rewrite it as negative b over 2 times A. And that helps because when the negative is right in the middle, the way it's typed, sometimes students think that they should make the top negative and the bottom negative, and that actually goes positive. 2 negatives make a positive. So I take this and I just boop it right to the top. Just make the top negative, not the bottom. 2 times A. And this is a formula. We'll talk about where the formula came from later in the chapter, but for now, we're just grateful to the mathematicians for helping us with a formula to find the axis of symmetry. What is an axis of symmetry? Mm-hmm. Well, it's the middle line that goes directly through the middle. And you probably heard this first in science class when they say the Earth spins around an axis or it's tilted on its axis. It's the line through the middle of the Earth. What's the line called through the middle of the Earth? I know, but that's the one that goes this way though. Baby, prime meridian? Or is that how we count? Isn't the prime meridian like the equator but this way? Does it go right through the middle, like the poles, North Pole, South Pole? Maybe it's the prime meridian. There we go. So all of our parabolas have an axis of symmetry too, which is really nice. It cuts it all in half. Okay. And the last thing I want to highlight here is the y-intercept. That's the literal number from the equation. The constant at the end is the y-intercept. With linear equations, y equals mx plus b, b is the y-intercept. Now we're going with c as the y-intercept. Okay. So this is a little bit more involved than just counting right, left, up, down. So the directions can ask a wide variety of things. So let's just look. This is like 5 different things we have to do here. It says we need to figure out the y-intercept. Fine. We also need to do the equation for the axis of symmetry. Okay, fine. We also need to find the vertex. So let's make a note here. Vertex is the very middle point. We also have to find domain and range, and we're going to actually do that this time. Then, lastly, we're asked to graph the function and make a table. So it's like 5 different things here, 5 different skills on the standard form day 1 handout. So what you want to do is when you try to do this on your own, you're going to pull this out, and you're going to go through these steps here. Step 1, step 2, step 3, step 4. All these steps will get this answered completely for you. Step 1, figure out the ABC. So it's y equals ax squared plus bx plus c. So a is supposed to fall right in front of x squared. This time we don't see anything, so it must be an invisible 1. A is 1 for this equation. We'll get more complicated here as you move on. B, in the B spot, we see a 2. B is 2. And in the C spot, we see a 3. C is 3. 1, 2, 3. Nice. So then we know that the y-intercept is 0, 3. because it's always the C value. I want to do red. So the y-intercept is where we can put a point. We've already got a dot on our graph. Any graph. Are we ready for step 2 or did I go? No, you had you. Okay, then step 2 is to do the whole formula, that whole middle line, negative b over 2a. So since b is 2, that's what I put in. I'm going to plug in these numbers that I just listed. 2 goes in the b spot, and 1 will go in the a spot. And go ahead and simplify that. You already get your calculator out. So we'll draw a dashed line at negative 1, and that'll be the middle of our parabola. Okay, right here, x equals negative 1, dash line, and I like to call that AOS, axis of symmetry. Take the b, make it negative divided by 2. Axis of symmetry. It's written here in bold. AOS. What's your the red one? That's the y-intercept. The 3? Yeah. Okay, so Kenny's bringing up a good point. What are we looking at? Since we have a line of symmetry, we can reflect this 3 over. You can reflect anything across this line. So we can go ahead and make another point right here. And now I can really see how this is the middle, and there's symmetry there. You can fold it over. You're looking at it. All right, step 3 already. Zooming through this, determine the vertex, the center point. So to get the center point, we take this answer, this x value, and we plug it into the problem. So plug in answer to step 2 into the equation. So whatever answer you got here, this time we got negative 1, we're going to put in an x here, and x here, plug it in 2 places. So it's going to be y equals negative 1 squared plus 2 times negative 1 plus 3. What is the other one? This one here? I was able, since I know that this is a reflection line, and kind of like, what you said, you fold it. I did the fold and put it there. I wonder how symmetrical the globe really is. I think it's really symmetrical. The moon looks like a perfect globe. It's insane. I sometimes look at it and I wish it looked more bumpy. It's unbelievable. Speaking of symmetry, you do this math real quick. Let's see if you can get it right. In the TI-36, you put this all in at once. You don't do this to enter, this to enter, this to enter, and combine it. You do a parenthesis, negative 1, parenthesis, square it, plus sign 2, parenthesis, negative 1, parenthesis, plus 3. You only hit enter once if you really want to get efficient with that calculator. You got to practice it. So you want to be able to do your calculator without even looking at it. We're working on that. Yeah. Okay, we're right there. So this was the answer done by hand. So negative 1 squared, positive 1. 2 times negative 1 would be, so I bring the plus sign down. 2 times negative 1, negative 2, bring the plus sign down. 3. 1 plus a negative 2, that's just 1 minus 2. Plus 3. Negative 1 plus 3 is 2. And this is your vertex. The negative 1 you plugged in, and 2 you got out. That's an ordered pair. That's a point. You plot that on your graph. It'll fall right on the dash line. So there it is. Now, last chapter I had you guys remember the parent function. So you can apply those skills right now. Since there isn't a stretch or a shrink here, we're at our center, and then it goes over 1, up 1, and then from here it would go over 2, up 4. So you can go ahead and draw your parabola at this point. When the equations get more difficult, there's decimals here, there's different numbers in the a value, there's stretches and shrinks. That was kind of the hardest part about last chapter. You're going to rely on making a table. So let's continue to step 4 and see how this table will work. This is usually where I lose people. People are good until step 4. They go home, they try it on their own, and then they say, I don't know how you came up with the table. So we'll revisit it tomorrow. But I should see for everybody at least dash lines and vertexes these first few steps. And you can use your book. There'll be a video. If you get lost, you can pull up the video. Okay. The table says to use the center point as the vertex. So right here, I'm going to put the point I just found right in the middle of the table. Which makes sense because the vertex is the center of the parabola. It's also the center of the table. Makes sense. So this guy came right here in our table. Now you want to do 2 points lower. So from -1, it would be -2, -3. And then on the other side of the vertex, you do 2 points higher. So 0, 1. This will help you get really precise points. And some people, even though the process takes longer, some people really like this better than what we just did last chapter. They feel more confident in it. All right, we're plugging all of these into the problem. And so y equals x squared plus 2x plus 3. So this is your chance to practice that. See if you can get the right number out. -3 squared plus 2 times -3 plus 3. I'm not going to plug in the 0 because I already know that's the y-intercept. So I'm going to pause for a minute and give you guys a chance. Try to simplify and get the right number out. Anybody get stitched when they plug in -3? Yes, good job. when you're done, you should see symmetry in your table. Unless there's a fraction or something involved. You know, you got your center, and then these should repeat outwards. So I can add these points. Make sure it doesn't look pointy. Should be a U shape, not a V shape. Mine looks so pointy. The little graph is too small. And that's it. Those are your steps that you want to try to move through. I've assigned you 2 of these in the book. So let me hit that domain and range and we'll be done. We will be testing domain and range this chapter. We'll talk about it more throughout. The domain is all real numbers because it can go right and left forever. It's infinities for domain. The range, however, is limited. It goes to infinity. It's too light. This color? Here, use black. You can't see any of it, or just the these tiny ones. You can come right here. And I could also zoom in a little bit. So. Boom, boom, boom. Okay. Anybody want to talk about that range? How does that range look like that? When I observe a parabola, I read it left to right. I'm going down. Stop here. I turn around and go back up. I never go below 2. So the range then goes from 2 to infinity. The lowest value is 2 and it heads up to infinity. All right. So you need your chapter 2 book pages. So the chapter goes from page 99 to 173. And the answer key is A13 to A20. So you'll probably do